Hi, welcome to Hands-On with Force Effect. In this series, we'll be looking at how to calculate the velocity of a projectile thrown from a Mousetrap catapult. In this part, we'll be looking at how to calculate the torque generated by the spring on our Mousetrap. To begin, we need to launch Force Effect. Once in Force Effect, I'll begin a new diagram by clicking on the screen. Now to get started with the actual diagram, I'm going to import a sketch mock-up of our Mousetrap catapult. And this could be any image. It could be a photo, it could be a scan of a napkin sketch, or even something you created in Sketchbook on your iPad. We're going to select an image from the photo gallery, and we'll use this image as a framework for drawing our diagram. We'll start by adding an element that represents the base of the Mousetrap. To do this, make sure the element option is selected in the menu, and then tap and drag along the base of the Mousetrap. As you near the end point of the line, if you slow down the drag, a magnifying glass will appear that will allow you to accurately locate the end point of your line. To do this, make sure that you have the element option enabled in the menu, and simply tap and drag along the screen somewhere near the base of the Mousetrap. Near the endpoint of the line, if you slow down, a magnifying glass will appear, allowing you to accurately locate the endpoint of the line. Now on the screen, you'll notice that the dimension tells us that it's 117 inches long, and we know that's not the case. To fix this, we can tell the first line exactly how long the Mousetrap is, and from that point forward, that dimension will be used by the system to scale any other elements we create. To change it, we simply tap on the dimension on the screen and enter the accurate value. In this case, our Mousetrap is 4.75 inches long. Now you'll notice if I go to my selection tool and tap that line again, that value has been entered. We're now ready to create the element that represents the throwing arm of the catapult. Again, we'll select the element tool, and we'll begin drawing our line near where the spring meets the base of the Mousetrap. Once again, when nearing the endpoint of the line, you can slow down and use your magnifying glass to accurately locate the endpoint. In this case, we've got a 3.4 inch long throwing arm. We now have all the elements we need for our calculations, but there's a few more steps we need to take. We need to lock the base of the Mousetrap to the table. We can do this by grounding the base of the Mousetrap. We're going to select supports from the menu, and then select the grounded option from the submenu, and tap on the endpoint of the line to ground that line. The first calculation is to determine the torque generated by the spring. Then we can use that value to calculate the force being applied to the projectile, and in turn calculate the speed at which the projectile is being launched. To calculate the torque, we need to weld the joint where the spring and base connect. We can do this by clicking on our selection tool in the menu, tapping and holding on the intersection point, and changing the joint from a standard joint to a welded pin. You'll notice that the diagram updates to indicate everything is grounded because of adding that welded joint. And that's fine for this calculation. Now that the throwing arm is welded to the base, we can add the force required to pull the arm back on our Mousetrap. We can do this by clicking on the Loads menu, and then tapping and dragging a force near the endpoint of the throwing arm. You'll notice as we drag along the screen, the force does snap to a perpendicular location, and when you release your finger from the screen, you can enter your exact value. In our case, the force was 1.13 pounds of force. If you measured your own force, you'll want to enter that here at this point. Next, we need to position the force exactly where we need it. We're going to go to the selection tool in the menu, tap on our force, and if we tap and drag, you notice that you can move this up and down the throwing arm. I'm going to tap on a dimension to enter an exact value. We know that our throwing arm is 1.725 inches long. We now have that force exactly located where we need it, and we'll want to remember this distance because it's a way for us to check our numbers. If we tap on the throwing arm element, we can see that the torque value has been calculated by Force Effect. In this case, it's showing 1.949 pound-inches of force. We can double check the math now just to ensure we're on the right track. If we take the length of our Mousetrap arm 1.725, and we multiply that by the force, 1.13, we get a value of 1.94925, which is very, very close to what we see on the screen from force effect, so we know we're on the right track.